So, a very good evening to all of you, those who are present here. So, I welcome you all on this session of Enable Plus Class 12 Physics. And the topic that we are currently studying is current electricity. Okay, clear? So, Darshana is asking, where is Akshmala ma'am? Akshmala ma'am is on a school visit. We will be coming by the end of this week, I guess. Or maybe yesterday, or sorry, maybe tomorrow or day after tomorrow. Till now, I am here to bore you. ठीक है, थोड़ा सा बोर होंगे, थोड़ा सा सीखेंगे, थोड़ा सा मजे करेंगे. ठीक है, क्लियर है दर्शना? अनम्यूट करके यस सर नो सर भी बोल दिया करो यार. ऐसा क्या हो गया? ठीक है, तो एवरीबॉडी इज फाइन ना? मेक श्योर द स्क्रीन इज विजिबल एंड आई एम ऑडिबल टू एवरीवन.
Yes, sir.
ओके, वेरी गुड. हु इज दिस? ये कौन बोला भाई? मधुकर रेड्डी सेइंग यस. आई थिंक जेनवी येचुली तरुण अनुषा भगत. ठीक है, वेरी गुड. ठीक है, ज्वाइन करो जल्दी जल्दी, देन वी स्टार्ट द सेशन. इट्स ऑलरेडी 4:06. चलो एक पोल भी लॉन्च कर देता हूँ. जस्ट आंसर इन द पोल कि क्लास स्टेटस क्या है. क्विकली आंसर इन द पोल एंड देन वील स्टार्ट द सेशन. अरे, quickly answer in the poll. Only 15 student has participated. 34 is present here. We have a lot to cover today. Okay. Very important and very interesting. Acha, one question I want to ask you. Can I ask one question to you, everyone? Can I ask something to all of you? Everyone has to answer. Everyone. Okay, JNV Bhavnagar से है दर्शन. Are you really enjoying my session? Are you really getting something? Answer very honest. Honest answer चाहिए. In that way, I'm going to improve
Yes,
myself.
sir.
I always have a lag in myself ki this is not the one, this is not 100%, and that is why I'm improving myself on a constant basis. Okay. Anything in this Enable Plus program, in this lecture of physics, especially for me, that I can improve. Any suggestion from you guys? Any suggestion would be welcome. कोई भी कोई भी ऐसा suggestion that you want to add up in this lectures or add up in the session that you have in your mind that this should be also in this class or this must be in the class. Tell me. Oh, I think I should add more and more number of questions that is related to JE and a little bit higher level of JE, na? For more conceptual clarity. That is from my side. What do you say, guys? Everyone. Okay, 43 participants is here. 42. चलो स्टार्ट करते हैं सेशन, हाँ. So today's goal is to just have a look about the current density. That is very important by point of view of JEE examination and need also. And concept of drift velocity. Somehow these are related, and we are going to relate them. Okay. And then from concept of drift velocity, we reduce a relation of combination of resistor. Okay. So that is the aim for today's class. Nothing much, nothing more. Okay. Let's just get started with it. So first of all, you see the current density, definition of current density, and then I make you understand what is the core of, what is the meaning of it actually. Current density is very simple. It's the current per unit cross-sectional area. And I have told you when we talk about the cross-section, na, suppose uh, there is a cylinder like this. So when you cut the cylinder on perpendicular axis, the axis of cylinder is this. When you cut the cylinder perpendicular to the axis of it, then the cross section you will see is the cross section. Okay, clear है? There is a longitudinal section also. Clear? When you cut along the axis, but when you cut the particular object perpendicular to its axis, it's a cross cut or cross section. Okay. So current density is basically represented by J, and J is nothing but what? Current divided by area. Now there is a hack of it कि this current density is a vector quantity. Why? Because देखो, current itself is not a vector quantity because it does not follow the vector law. But upon में I upon A है. A is what? Area. And we have seen in the Gauss law कि area behaves as a area vector because of the magnitude and the direction. We have seen in the previous lectures. So that is why this will become a vector quantity. J vector is equals to I upon area vector. Now, which area you have to take, that is also a point. Okay. So, in this cylinder, you can see here, this is a conductor. Current is flowing in this direction. Let's see. So, we have taken a we have taken a tilted area here. This. Okay. And this type of area we have taken. Got it? Which is making an angle theta degree with the origin. So this particular area is tilted like this. Okay. So when we resolve this particular area into two components, so one of the component will like this, a sine theta, and one of the component will be a cos theta or s cos theta, whatever you are preferring. Now, current can pass through which part of the area? This one, which is cross sectional. So you always have to take the cross sectional area. Okay, always have to take the cross sectional area or the area which is perpendicular to the flow of current. ठीक है, देखो current is flowing in this direction, these red lines, and the area you must taken as this, the perpendicular area. Clear है? So here, if you will see that J will become I upon a cos theta. So from here you can say that I is equals to J a cos theta, and since if I assume that this area is very small, I can say that I is equals to J dot dA. Suppose area is not uniform. Let me write it here. if area is not uniform, if area is not uniform, then what will you do? Like this type of area is given to you. देखो, at each and every point of time, at each and every point of space, the area is changing. So in this particular situation, you can say that current here, current is also very small, di, current is also very small from a very small area. So it will become j vector dot dA vector. And if you want to calculate the total current I, you just have to integrate this. Okay? This must, you should keep in mind. We solve a very good number of questions from this equation. Okay? Now, any kind of doubt? Anyone? किसी को कोई डाउट है? ये फॉर्मूला आपको तभी अप्लाई करना है. दिस फॉर्मूला यू ओनली हैव टू अप्लाई व्हेन द एरिया is not uniform and if current density is not constant. Current density is a variable thing if it is given in the question. Like current density is given as a function of x or a function of time. So in that case also you can apply this. Clear? So in these two situations you are going to apply this formula. Otherwise you can apply the very simple formula I is equals to j into j vector dot a vector. Okay. Now very important thing I am going to write here is that for steady state of current. Steady states का मतलब क्या होता है भाई? What do you mean by steady state? Tell me in the comment box. What do you mean by steady state of current? Tell me in the comment box what do you mean by steady state, everyone. Or you can say by unmuting yourself also. Very good. Okay. तो स्टेडी स्टेट का मतलब होता है whenever, स्टेडी स्टेट का क्या मतलब होता है? whenever the object or the particular system is not changing with respect to time, that particular state, or you can say it equilibrium also, that is a steady state of current. तो जब current का magnitude is not changing with respect to time, that particular, at that particular situation we can say the current gain its steady state. So in that state j is always constant, j is always same. ठीक है? Like there are two wires which is connected to each other, and in both the wires steady current is flowing. So you can say the current density for this wire and the current density for this wire is same. So J1 is equals to J2. You can say that. Clear? I hope you are clear with this current density. Now, let me move to the next page. Here. Now, we will discuss about the concept of drift velocity. Okay. So firstly, you need to focus on this diagram, on this particular ammunition. So we have a river boat here. This blue color is a boat, not a bullet. And this particular thing is river. Okay. And this boat is crossing this river without the motion of this river and with the motion of this river. Okay. So this is river here. with no current. Current means is not only related to electric field, everything that is flowing from higher potential to lower potential, higher altitude to lower altitude, ठीक है, higher pressure to lower pressure, that everything is termed as current, ठीक है. So here in this type, the velocity of the river is in this direction. So you can say that, you can here see, if the boat is crossing the river without current, there is no change in the path. It's simply a straight line. But when it's changing, when it's the river is moving, the water inside the river is moving, then there is a certain change in the point where the boat want to reach and where the boat has reached. So this particular distance is called the drift. And this drift has come because of the movement of river. Okay. Whatever the force that river has applied on the boat, because of that, the river had the boat has shifted itself. ठीक है. अगर रिवर मूव नहीं कर रही होती तो देर इज अ स्ट्रेट लाइन पैथ, देर इज नो चेंज. इन सिमिलर वे, when there is no electric field present, so we have seen that if I draw a particular cross section here, these white color dots are electrons. So we see that in the absence of electron, when, let me change color here, when electric field is zero. So in this case, we can say, and we have seen in the definition of current also, that for a particular cross section, delta Q, which is the net charge, is always zero, which is crossing this cross section. Okay. Why? Because they have a random direction. They have a random direction of velocities. Okay. That is why the amount that is going left to right, the same amount is going right to left because of the randomness in the motion. So net value of current, sorry, net value of this charge flow is zero. So over a period of time, the current is also zero. Clear? But when there is an electric field, when electric field is present, electric field is present. So let's say the electric field is in this direction. So electronic movement will be happening in the opposite direction. इसमें किसी को कोई डाउट है? The electron will experience a force minus E times of E vector, which is coming from an expression F is equals to QE. So each and every electron will experience this force, and whenever the force is applied, there is an acceleration. But the fact here is, electron will not have the time to being accelerate itself. इलेक्ट्रॉन के पास टाइम ही नहीं है एक्सेलरेट करने का. क्यों नहीं है वो टाइम? देख, जैसे ही इलेक्ट्रॉन यहां से मूव करेगा, लेट से यहां से मूव किया, मैं यहाँ पे आपको दिखाता हूँ एक सिचुएशन. दीज आर द पॉजिटिव चार्जेस एंड दिस इज द पर्टिकुलर इलेक्ट्रॉन. सो वेन एवर दिस इलेक्ट्रॉन इज बीइंग pushed by this force, ठीक है, so due to the presence of this bulky positive ions, the electron will collide to them. और जैसे ही कोलिजन होगा, द वेलोसिटी विल चेंज, एंड द चेंज इज वेरी रैंडम, कि किसी भी डायरेक्शन में जा सकता है. सो इट विल हैव अ टेंडेंसी टू मूव इन रैंडम डायरेक्शन, which means at that particular time velocity is being changing. अब लेट्स से यहां से टकरा करके इस पर्टिकुलर आयन के साथ कोलिजन के बाद ये यहाँ पे आया, इस आयन से कोलिजन किया, तो इन दोनों के बीच में सेपरेशन अगर लेमडा है, so it has to travel at distance lambda, which is very very close, okay, which is very very small. So to cover this distance lambda, the time spent by this electron is also very small, and let's say this is tau, very small time. So electron does not have the sufficient time to accelerate itself, okay, although the acceleration is also there, but a very minimum value, okay. It does not have a significant time to show the accelerated motion of it, ठीक है. एक्सेलरेशन तो है, लेकिन एक्सेलरेटेड मोशन को शो करने का टाइम नहीं है, ठीक है. टाइम इज वेरी स्मॉल. तो लेट्स से इनिशियली Initially, when इलेक्ट्रिक फील्ड इज जीरो, ठीक है, तो इस पर्टिकुलर क्रॉस सेक्शन से कितने इलेक्ट्रॉन पास हो रहे थे? नेट इलेक्ट्रॉन पासिंग थ्रू दिस क्रॉस सेक्शन इज zero, because whatever the electron is passing left to right, the same number of electron is passing left to left, ठीक है. So when electric field is zero and number of electrons is n, ठीक है. So I can say that the average velocity of electron initially is equals to zero. Can I say that? Which is equals to v1 plus v2 plus v3 plus v4 up to vn divided by n. Can I say that? किसी को कोई डाउट है इसमें? एवरेज वेलोसिटी इज जीरो बिकॉज वी आर नॉट गेटिंग एनी मूवमेंट. अगर हमें मूवमेंट मिल गया तो देर इज अ वैल्यू ऑफ करंट देयर, बट करंट इज नॉट देयर, विच मीन्स द इलेक्ट्रॉन इज नॉट मूविंग. Although the electron is moving with a thermal motion, but supposingly here we can say that the average velocity of the electron is zero for all the electrons. Okay, for all over the picture, whatever the number of electron. ये जो इलेक्ट्रॉनिक मूवमेंट की बात हो रही है, ये एवरेज वेलोसिटी इज नॉट फॉर, this average velocity is not for an individual electron. This is for the bulk of electrons, all the electrons present in the conductor. Now I hope that you are getting it. इसके बाद when electric field is applied, ठीक है, let's say when electric field is applied across the conductor, across the conductor, ठीक है. So across the conductor there is electric field we have applied. So now if I talk about for an individual electron, if I say, and this electric field is uniform, this electric field is uniform also. So can we say that this particular motion is uniformly accelerated motion for a particular electron? Yes, we can say that. So for individual electron, I'm writing it. For individual electron, if I want to calculate the final velocity, let's say V final is equals to U initial plus acceleration into T. We can apply that. V initial, U initial, we can say minus E कैपिटल ई अपॉन एम इंटू टी. अब बहुत से लोग सोच रहे होंगे ये एक्सीलरेशन कैसे आया. तो वी हैव अ फोर्स इज इक्वल टू माइनस ई इंटू कैपिटल ई. फोर्स को वी कैन राइट मास इंटू एक्सेलरेशन minus e capital E, and then we can say that acceleration here is minus e capital E upon m. Can we say that? Yes, we can say that. Okay, चलो वेक्टर साइन अभी हटा कर रखते हैं. And this is V final. This is for individual electron, but we are calculating it over the conductor. So for n number of electron, what we are taking? We are taking the average of this equation. We are taking the average of this equation. So average of V final is equals to average of U initial minus average of this complete term E capital E upon M into T. Clear? अब देखो, प्रीवियसली इफ आई शो यू, यहाँ पे एवरेज वेलोसिटी ये कौन सी थी? इनिशियल वेलोसिटी थी ना. दिस इज द इनिशियल वेलोसिटी इनिशियली. So initial average velocity for an electron is what? Zero. So initial velocity for an electron is zero. So this term will become zero. Now, average final velocity is equals to now this electronic charge, capital E and mass. This is fixed. So we can take it out from this average term. So now we can say this is E capital E by M into average of time t. देखो अब यहाँ पे this is very important to understand. Suppose this electron is moving from here to here. This electron had a collision with this particular ion, ion number 1, and now it's heading towards ion number 2. So it will spend some time in this collision. Okay, spend it some time in this collision. After collision with this ion 2, let's say it collide with this ion number 3. So can we say that the time taken by this, let's say T1 in this first collision, and in the second collision the time is T2, and relatively time taken in third collision in T3, fourth collision in T4. So can we say that this T1, T2, T3, T4 are same? No, we cannot say that, because the gapping between the ions is also very small. And one of the important factor here is that after each and every collision, the direction of velocity is very random. Okay? So that is why the time spent in the collision, between the collision, is different for each and every collision. So we cannot say that this is these are not equals. Okay? So I'm writing it here that time spent in each collision is different. So that is why I'm taking an average value of this time. So here you can say that average velocity final is equals to minus of E capital E by M into tau, where tau is the relaxation time. And what is relaxation time? The time spent between two successive collisions. अभी कोलाइड किया, उसके बाद दूसरी कोलिजन तक द टाइम इसने स्पेंड किया, दैट पर्टिकुलर टाइम इज टाउ, द एवरेज रिलैक्सेशन टाइम. ठीक है, क्लियर है सभी को? एंड दिस एवरेज फाइनल वेलोसिटी विल बिकम vd, which is the drift velocity. This is the drift velocity. Okay, so we can say that drift velocity here is equals to what? Minus E capital E upon M into tau. M into tau. Clear है? Now from here you can say that, yeah, PM Shri Anashura. और आप हाँ बताइए भाई, क्या डाउट है आपको? व्हाट इज योर डाउट? आस्क आस्क योर डाउट. जब तक ये डाउट पूछते हैं, वी विल हैव दिस कॉन्वर्सेशन हियर कि दिस ड्रिफ्ट वेलोसिटी इज द एवरेज वेलोसिटी. ठीक है, देखो, ऑल्दो इलेक्ट्रिक फील्ड इज अप्लाइंग अ कांस्टेंट फोर्स and the electron is being accelerated, since also this particular drift velocity is independent of the acceleration, independent of time. This is of independent of time. ये बहुत इंपॉर्टेंट चीज है, इंडिपेंडेंट ऑफ टाइम. मोस्ट ऑफ यू विल बी थिंकिंग दैट इट डिपेंड्स ऑन टाउ, ना टाउ इज द रिलैक्सेशन टाइम. दिस इज एवरेज रिलैक्सेशन टाइम. ठीक है, सो एवरेज वैल्यू इज अ फिक्स्ड वैल्यू. क्लियर? क्लियर है सभी को? तो इसे नोट कर लो आप. VD इज इक्वल टू माइनस ई कैपिटल ई अपॉन एम इंटू टाउ. ठीक है, Okay. Now I just want you to move a little backward here when we are discussing the current density. Okay. Now we know that the current density is nothing but I upon A. Clear? Thank you so much, Jane with Anasura. Thank you so much. Okay. So current density here we are studying as I upon A. Clear? Now, if I just ask you, what is Ohm's law? Ohm's law is V is equals to I into R. Okay. If I made some modification in this Ohm's law, कैसे मैं modification करूंगा? So the first relation that I'm going to use is that dV or delta V, which is ultimately you can take B, is equals to E electric field into L. If the length of the conductor is L, if the length of the conductor is, let's say, L, this is the conductor of length. I know that conductor is not looking fine, but you can take it. Okay, conductor length L. So across it, a potential V is applied, and it is developing an electric field inside it. Okay, so that is why I can relate it here. And R we can write as rho L upon A. So putting the value in this equation one, what you will get? V is equals to E into L, I into R का value rho L upon A or small L upon. Now, if you put the value of current density here with respect to in terms of I, so EL is equals to J into A into rho L upon A. Now this L and L will cancel out. This A and A will also cancel out. So this E vector here is, you can say, is J vector into rho. This is another form of the Ohm's law. And one of the form is when we know that 1 upon rho is nothing but sigma, which is conductivity. Conductivity. So you can replace 1 by rho with sigma or one rho with 1 by sigma. So when you do so, this J vector will become sigma E. These are the other forms of Ohm's law. Ohm's law verification, eh? Ohm's law. Because electric field is representing the potential difference, it arises due to the potential difference. Rho is the resistivity, R you can relate, and G is current density. So it is also similar to the V is equals to IR. Got it? This is also the other form of Ohm's law. Other form of Ohm's law. Okay? Note down? Note down कर लिया आपने? Everyone? Everyone, have you noted down? Say yes and no in the chat box. And at any point of time, if you are having a trouble with the concept, you are having any doubt, just try to ask me. ठीक है? ओके, कोई भी डाउट हो तुरंत पूछ लो अभी. चलो, ठीक है. Then move to the topic that we are studying, which is the concept of drift velocity. And here we are. Now, if I just add one more point here, and let's say, where do we do it? Um, okay, here we will do. Let me change the screen. Relation between, ये बहुत इंपॉर्टेंट है. Relation between current and drift velocity. Current and drift velocity. Okay. So the very famous relation is I is equals to N E A V D. This you must remember, where only one thing you need to remember, which is N. N is the number density of electron. Number density of electron. Okay. Which means number of electrons per unit volume. Clear है? ये आपको याद रखना है. Now we can also have a relation between J and D here. देखो, if I put the value of I in terms of J, it will become J into A is equals to NEA VD. Cancel this A. So you will have J is equals to NEV. Clear? Now, if you put the value of VD in this expression, so J will become, in both the expression we are going to put it, N into E. What is the value of VD? VD is E capital E upon M into tau. I'm taking the magnitude only. So J vector here is N E square capital E upon M into tau. This is also a relation. And when you put the value of J in terms of I, this is I by A. So only A also multiplied here. So we can say that I is equals to what? N E square A upon M E tau. So this is also we can say. These are the also two relations. Okay. Now the question here is, what if what if we we raise the temperature of conductor. कंडक्टर का टेम्परेचर अगर हम रेज करेंगे तो देखो क्या होगा. ये मेरे पास एक कंडक्टर है जिसमें बहुत सारे पॉजिटिव और नेगेटिव आयंस हैं. ओके. जैसे ही मैं टेम्परेचर रेज करूंगा, एज आई विल रेज द टेम्परेचर टी ऑफ दिस, सो क्या होगा, क्या थर्मल मोशन इंक्रीज हो जाएगा? बिकॉज वी नो दैट ईटी थर्मल एनर्जी इज 3/2 kb into t. So by increasing the temperature, ET will also increase. And if it is increasing, then the thermal motion of the electron will increase or the ions will increase. So ion will vibrate more. Ion will vibrate more. Due to the enhancement in the vibration of the ions, positive ions, the electron will hindered more. अब इलेक्ट्रॉन के टकराने की प्रोबेबिलिटी ज्यादा हो गई है, बिकॉज अभी मान लिया ये यहाँ पर था आयन, यहाँ पे आने में टाइम लगेगा तो इलेक्ट्रॉन पास आउट कर जाएगा. बट नाउ इट इज वाइब्रेटिंग विद अ वेरी हाई स्पीड. सो इन दैट केस वी कैन से अब इलेक्ट्रॉन जल्दी जल्दी टकराएगा. तो जब जल्दी जल्दी टकराएगा, इलेक्ट्रॉन विल कोलाइड मोर एंड मोर फास्ट. सो इन दैट केस व्हाट वी कैन से, द टाउ, जो टाइम है, रिलैक्सेशन टाइम, द सक्सेसिव कोलिजन के बीच का जो टाइम है, दैट विल इंक्रीज और डिक्रीज. दैट विल डिक्रीज बिकॉज अब जो कोलिजन हो रही है, द कोलिजन दैट इज हैपनिंग राइट नाउ इज मोर रैपिडली हैपनिंग. सो द रिलैक्सेशन टाइम, the time spent between two collision is being reduced. So tau is reduced. So if tau is reduced, you can say here, if tau will reduce, current will increase. ठीक है. Or we can say that, देखो, in the previous equation, if you just relate it with the yeah, J इज इक्वल टू एन ई स्क्वायर अपॉन एम इंटू टाउ। दिस एक्सप्रेशन को बात करते हैं। आई थिंक ये आपने नोट कर लिया होगा, तो आई एम रफिंग इट। We recently deduce an equation J is equals to rho E is equals to rho into J। ठीक है। Can we extract the value of rho from here? Let me draw it with another ink. Can we say that this particular value is the value of rho and E square tau upon m? So from this equation we can say rho is nothing but n E square upon m into tau, which means rho is directly proportional to tau. So as tau increases, rho will also increase. So we can say that on increasing the temperature, the resistivity of the temperature will increase. Okay, can we say that? Yes, we can say that. And why it is increasing? Because relaxation time is, sorry, it will be 1 upon rho, I think. Let me just check the expression here. What we have did in the previous slide. Here. E is equals to J rho, which means it is 1 by rho that is we are actually talking about. The thing that is multiplied with E is sigma. ठीक है, just a little mistake. ठीक है, चलो. So the thing that I am talking about is that we are having a expression of J is equals to what? J is equals to N E square upon M into electric field into tau. So if I just rearrange it, N E square tau upon M into electric field, this is J. And we have another expression also. J is equals to what? J is equals to sigma E, which means this is the value of sigma. And sigma is 1 by rho. So can I write rho is equals to M upon N E square tau? इसका रिवर्स हो जाएगा, बस इसका उल्टा हो जाएगा, बिकॉज सिग्मा इज N E square tau upon M and rho is 1 upon sigma. So on increasing the relaxation time, ठीक है, on increasing the relaxation time, the resistivity will increase. ठीक है, सॉरी, on increasing the temperature, ये reduce हो रहा था ना, तो on increasing the temperature, let me write it here. On increasing temperature, increasing in temperature, tau will reduce. As tau reduces, so resistivity will increase, and sigma, which is conductivity, that is decreased, because rho is inversely proportional to tau and sigma is directly proportional to. Clear है सभी को? Any kind of doubt in this? Yes and no? Any kind of doubt, guys? Everyone? Vedant, JNV, Dhansura. Okay. Darshana. If you have any kind of doubt, you can ask. ठीक है, चलो. If you don't have any doubt, try to solve this question. A copper conductor of increasing diameter has been shown in figure. Which of the following quantity vary along the length of the conductor? Current density, electric field, resistivity and drift velocity. तो आपको बताना है कि इनमें से कौन कौन सी जो क्वांटिटी है वो वेरी करेंगी लेंथ के साथ. जे, इलेक्ट्रिक फील्ड, रो एंड वीडी. देखो, if I just focus on this current density, J, J is nothing but I upon it. Okay. which means J is inversely proportional to area 1 by. So here you can say the area of cross section is, let's say, A, and here the area of cross section is, let's say, B. So we can say that B is greater than, which means here the area is larger, and here at the one end the area is less. So area is increasing. So as area increases, the J will decrease. So which means at J at point A is greater than J at point B, because at point B we have a large area. Clear? Okay. Now same thing you can do with the electric field also. J is nothing but sigma into E. So J at A, sigma E A. Sigma will not change. Sigma is the property of the conductor. And throughout, here it is also made of copper. Here is also made of copper. Here it is also made of copper. So the complete wire is made of copper. So there is no change in resistivity and no change in conductivity, because these are the extrinsic properties. Okay, property of the conductor. Clear? But as you can say, on the current density, electric field is directly dependent. So electric field at point A is greater than electric field at point. Clear? Similar way you can do it for drift velocity also. That Vd is nothing but minus E capital E upon m into tau. So depending on E, same variation with Vd also. Clear है सभी को? Everyone, any kind of doubt in this question? Everyone, any kind of doubt in this question? कोई पॉइंट समझ में ना आया हो, यू कैन आस्क. ठीक है. नाउ combination of resistor, if I say. So this is a very simple topic. You have covered this topic in the 10th class also. So there are two types of combination of resistor. First is this, as you are seeing. If one end of the conductor is connected to the another end, let's say this is end 1, this is end 2, 1, 2, 1. So we can define these uh, combination in two ways. How? If the second end of the conductor, second end of the resistor is connected to the first end, then again the second end is connected to the first end. This type of combination is called series combination. But this type of simple combination you are not going to find. So what you have to do? Look, if the current passing through the conductor or the resistors are same, look, here the I current is generated, same current is going through this, same current is going through this, same current is going through this. So in this way, when current passing through each resistor is same, then we can say this particular combination is same. So the equivalent resistance that we can give here is just opposite to the capacitance, R1 plus R2 plus R3 plus R4 up to whatever the number of capacitors. Here is one thing, that the potential will be different. Potential will be different. So you can say that V1 plus V2 plus V3 is equals to V. This is due to the conservation of energy. Okay? Clear? Now, and if let's say there is a combination of two resistors in series, how to directly find out the voltage across them? This is V1, this is V2. And let's say the resistor is R1 here and the resistor is R2. So by Ohm's law, we can say V is directly proportional. V is equals to IR, which means V is directly proportional to R. Okay. So to find V1, I'll tell you a trick here. V1 is nothing but take R1 in the numerator side divided by the sum of the conductor R1 plus R2 multiply by total current. Similar way में you can find it for V2 also. R2 upon R1 plus R2 into total current. ठीक है? So these two formula you can expect. Clear? Now same goes for the parallel combination. If anyone has not noted, so just let me know in the chat box. ठीक है? कि we haven't noted this. Shift ourselves to the previous slide. Clear? In parallel combination, the current is different in each resistor. Okay, but potential difference across each capacitor is same. ठीक है, तो जो पोटेंशियल होगा R1 R3 के अक्रॉस भी कितना होगा, जितना बैटरी प्रोवाइड कर रही बी, दिस R2 के अक्रॉस भी कितना होगा बी, R3 R1 के अक्रॉस भी कितना होगा बी. Because if you see, this end of the conductor is directly connected to the positive end of the battery. This end of the conductor of or resistor R1 is connected to the negative end. Similar way में for R2 also, this end is connected to positive, this end is connected to negative. Whenever there is another resistance come in between the resistors, जैसे कि in the previous case, look, this end, first end is connected to the battery, but this end is not directly connected to the battery. There are some resistor also. So there is loss of energy in that case. So that is why the value of potential will change. Okay, in series. But here the same end is connected to the same terminals. We can say the potential is same. Now what is the formula for combination? So it is 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. This way you can also learn it. One of the another way is also 1 upon R equivalent is what? Sigma 1 upon Ri, and I is equals to 1 to 10. The second expression will give an impact that you are preparing for JE, okay, or NEET. Clear? Now there is one more term that I want to introduce to you, and then after we are going to solve these questions. And this is the electric power. देखो एक बहुत ही ब्यूटीफुल सा एनिमेशन है आप लोगों के लिए. You can enjoy that. This is the electric bulb. Plug in the power, and then it is rising. How do you like this? Do you like this animation? So power is given by voltage into current, or I square R into R. There is another form also we can reduce. If you put the value of V in terms of Ohm's law, that is I by R, we can say P is equals to I square upon. Okay. Clear है? So these are the three expression of electric power. If you want me to elaborate more on this topic, you can let me know in the chat box for electric power. But these formulas are sufficient for you. But if you want me to elaborate more on this topic, you can ask me in the chat box. Now try to solve this question. Let's say this is R also, this is R, this is R, and this is also R. You have to find the equivalent resistance between A and B. So first of all, check whether it is in series or parallel. So उसके लिए सबसे पहले क्या करना है, जिन एंड्स के बीच में आपसे पूछा गया है ना, if it has been asking for A and B, between A and B, so try to draw a current from A. Let's say this current is drawing I from A. Now this current will pass through this resistance without any hesitation. It moves to this I, moves here, I, moves here, I, and then it comes back to here, which means in these three resistance R, R, and R, the value of the current is not changing, although the potential is different for each and every point. So what we can say that these three resistance are in series. So can we draw it like this? This, the one end is connected to A, and there is another resistance also, and there is B end here, which is connected to these. Okay, this is R, R, and R. So equivalent of these three will become 3R, and now they are in parallel with this. This is A, this is B. This is a parallel combination. So if a current is drawn, it will move like this and this. Okay. This is R also. So you can directly calculate for two resistance if they are in parallel. So it is R1, R2 by R1 plus R2. So it is 3R into R divided by 4R. 1 R will cancel out. So it will become 3R by. Now this question you will try at home or your school, because you stay in the hostel now. When you get back to the hostel, try to do it. Just note it down. Everyone, note it down. Okay. Chalo. So this is it for today's lecture. These are the questions that we want to do, but we will do in the next class. Okay. So how do you feel about today's class? Answer in the poll. And if anyone has any kind of doubt, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive and being a little bit responsive, because response is not coming in that way I was expecting. Okay, thank you so much, guys. Bye. Take care.